Now, the good news is we won't always necessarily, for the first couple classes, it probably will be mostly spending, most of the time going through material. But what each person in here is going to do is we're going to be working on a product. Okay, and we're going to be doing it with Unity Game Engine, which I'm going to be introducing to you over the next, starting today and then over the next several classes. So each of you will be as if you're your own software company. And you'll be making initially a idea paper and a requirements document that we're going to look at. It'll be due for next week. And I'll talk to you more about that here in a few minutes. But effectively what you're going to do is you're going to say, this is what I'm going to do, and this is the checklist of stuff that it will have. Okay? Now, it has to be done in Unity. It has some other rules associated with it that I'll talk to you about here in a little bit. But that checklist is something that I'm going to use to figure out, did you do everything you said you were going to do? Now, this is actually related to a project we've been working on here on campus for since the beginning of the summer. And then recently, Concordia Publishing House has shown interest in getting involved with that, which is, I think, kind of a big deal. So, how many of you have heard of the project we're working on campus called Bible VR? Okay, so what we're doing is we're taking Bible books and or stories from the Bible and turning them into virtual reality experiences. All right, and what each of us in here is going to do is we're going to pick a story from the Bible that you want to bring to life in what will ultimately be virtual reality. But when you first work on it, I'll show you in Unity. It's you can design it in just 3D non-virtual reality, because I assume not all of you have VR helmets at home. Okay. We do have several here in the department that we can come in and test, but probably the last several weeks of the semester will convert what you've worked on into VR. It's not that huge of a deal to do that. So initially it'll just be, you'll make a 3D game that is the Bible story. Now, more than one person in class might happen to choose the same story. That's okay. So that'll just be a direct competition, like whose is better. So one person will get an A, the other one will fail, depending on whose project was better. In terms of time commitment, so this is a 6-credit course. So you should be spending roughly 12 hours per week on this project. Over 16 weeks? So 12 times 16 is 192 hours. All right, so one of the things that you're going to have to turn in is a log of how you spent your hours. Now, so kind of clocking your time, if you will. Now, the good news is that you're going to be able to use some of those hours for this coming week, writing your requirements document and your idea paper. Okay, and we'll talk more about that here in a little bit. All right, so, and I realize the course isn't unlocked yet. I'll get it unlocked during one of our breaks. But breakdown for grades in the class, we're going to have your idea paper. There's not a right or wrong thing. Effectively, what you're going to say in that is, here is the Bible story I'd like to work on. So, for example, Edwin was talking to me the other day. He wants to do something dealing with Noah and the flood. Okay? Well, that is a pretty big thing. They've made movies, like hour-and-a-half long movies about that, right? Okay, so that's his broad idea. But now the game he's going to be creating, and if you're not a video game player, that's okay, because this isn't like an arcade shoot 'em up, chop 'em up type thing. This is more of a take a user through a 3D world experience of a story. Okay, so the idea maybe for the Noah story, it might be the idea of building the ark, but not one piece of wood at a time. Probably something like him and I were talking. I said, well, you kind of think back, and God gave Noah all these big pieces of wood to work with, and I'm sure you had to cut some of those down, figure out what kind of tools Noah would have had to use back then, and I need this wood to be this size. how would you go about doing it, and maybe take them through the experience of doing that one of the times, and imagine how that would play out in virtual reality. Because in virtual reality, you actually be holding the saw, right, or whatever it is that they're using, and you're actually cutting the thing. So before you bring that into VR, you'll kind of fake it with normal, keyboard controls or a mouse controller or something like that, where you'll hold on to the saw and drag it across. But you wouldn't do that for like the entire boat. You might do that for one or two pieces of wood or something like that, and then the idea is that then you fast forward and an entire boat is built. Or you paint the pitch onto the outside of the wood to waterproof it, that kind of stuff. So you want to imagine, go work backwards from the total number of hours that you have to work on this thing. I mean, you can work more hours if you want, but my expectation is what you'll accomplish will be done in 192 hours. But with that being said, well, 192 hours plus work we do in class. Because I'll be available as a resource during class, and we'll talk more about what classes might look like after we kind of get through the initial tutorial phase of bringing you up to speed on Unity and that kind of stuff. So in any case, you're going to be telling a story, and you're going to have to decide what would be entertaining for a user going through this experience, and how long should the experience be. If I'm a person playing your Noah story, for example, maybe, it's something that maybe takes me, 20, 30 minutes to play. Yeah. Well, no, that's how long the video takes. I'm talking about to play the game. So I start off, and maybe chapter 1 is build the ark. Well, maybe chapter 1 is God tells me to build the ark. Floods are coming. Okay. Chapter 2 is build the ark. Well, I'm probably not going to build the ark piece by piece, but, some part of building the ark. Then maybe chapter 3 is putting the animals into their pens or something like that on the ark. Okay, chapter 4 is now we're on the ocean, and it's, the ark is going around. So if you want to tell the whole story, from beginning to end, you're probably going to have to take some shortcuts in the middle and not have too much extra stuff that's happening in the middle, but instead, think about things that would be cool in virtual reality with Noah's Ark. Just the size of the boat, right? So if you create something that is to scale, what is it, 75 cubits wide, 300 cubits long, it's 75 cubits tall, 300 cubits long, and then how many cubits wide? How many? 140 cubits wide? So in any case, just being able to go into that space and look around, and you're inside the ark, and go up, and go to the different animal pens and stuff like that. Just almost like the ark experience. So that would be another route you could take with the Noah story. Instead of doing the story from the perspective of telling the whole Noah story of why he's building the ark, actually building the ark, floods happen, blah, 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 you could have, more of the ark experience, where you've built you have the boat, it's there, and you can walk around the boat, and there's tasks you could do around the boat, feeding the animals, stuff like that, kind of the things that Noah and his family would have had to do, while they were, at sea, that kind of stuff. So you have to kind of imagine what kind of experience you want to deliver. So this is going to be an imagination type thing, and also so you're going to pick a story that you think would be cool to tell in virtual reality. Then you're going to imagine, how am I going to tell this in virtual reality? Or if it's this huge of a scope and you need it to be this big, what's the first part of the story you're going to tell in virtual reality? Make sense? All right, so this idea paper is effectively your pitch for the Bible story you're going to tell, along with kind of, it's probably a one-page document or so, where you're going to tell me, here's the Bible verse, and this is the story that I want to focus on from that Bible verse or from that Bible story, something like that. Next thing is this requirements document. I don't have a specific format that I want you to follow with it, because really what I want this requirements document to be is to ultimately be a checklist. Something that you and I can sit down with at the end of the semester with your game running in front of me and go down this checklist and mark off the completion of all these different requirements. All right, so this is kind of where you're going to work backwards from 192 hours. You're going to say, okay, here's all the things I want to be in my game. Now, you are going to have to make some sort of assumption as to how much time different things are going to take you. Some things are going to take you more time than you expect. Some things are going to take you less time than you expect. But at the very least, when you're planning this out, just assume that the Unity programming tool isn't any more difficult to work with than normal programming stuff. So assume the graphics and a lot of that stuff is going to be taken care of for you, or won't be the end of the world type stuff. So you could estimate the amount of time, and you'll get a better feel as we get into it today for how long different things take. All right, but this is going to effectively be a checklist that lists all the things that you will accomplish in your project. Okay, and that should be detailed, so we can go through and mark off at the end of the semester, because 40% of your grade is going to be your adherence to those requirements. Now, as the semester goes on, if certain things start taking you way more time than you expected, you do have the opportunity, with my approval, to have certain requirements altered on your requirements document. All right, but you'll have to make an argument as to why that requirement can't be met, or why it needs to change for, to something else, because of some, whatever it is, you'll have to make the argument. So once you put it in your requirements document to begin with, and I approve the requirements document, I'm going to basically say, yes, this looks like appropriate scope. So a couple different things can happen with that requirements document. I can come back and say, this looks good. I can come back and say, okay, this looks like you're trying to do more than is really going to be accomplishable in the semester. So we might look at what things to take away to shrink it down to something that's doable. Okay? And then there might be a thing where we say it's there's not enough stuff here. Now, one thing that I'd encourage you to do, and we'll talk more about the kind of the requirement, but one thing I encourage you to do is be as granular as you can with that requirements document. Don't just put some paragraph here and says, I'm going to make the boat. Give me a breakdown of the aspects of that. The boat is, how many stories high? How many cubbies are there going to be for animals? Are there going to be staircases? Really break it down so, we have an opportunity to put down check marks. Okay, so the more detailed you are, the easier it'll be to put a check mark down next to it when we're grading it at the end, right? As opposed to you being very broad. All right, so 40% of your grade will be how well you've adhered to your requirements document. 25% of your grade will be that final project, what you actually submit, your final experience. Now, keeping in mind, we're not professional game designers. So I'm not looking for something that, I'm looking for it, but I'm not necessarily expecting something that, somebody would pay a lot of money for. At the very least, we're looking for a good starting point for the team of folks that are going to hopefully in the future keep working on Bible VR, to maybe take what you have and, either insert it into Bible VR or use that as a starting point and expand it to go into Bible VR. So doesn't necessarily need to be of quality that it's ready to sell, but I expect it to look like a lot of effort was put into it. There will be a presentation at midterms around week 8, where you'll get up and demo your kind of your progress on your project. This will be your opportunity to either embarrass yourself if you haven't made enough progress. So like, oh yeah, I really haven't gotten started. I've had a lot of homework in other classes. I lost a shoe. Whatever it is, that'll be your opportunity to make a fool out of yourself. So that's 10% of your grade, and then your final presentation is when you'll demo what should be your completed project, and that will probably be our last class meeting where we'll do that. All right, so any broad questions on what we're doing in class, or what we're doing in the course, I guess? Have a decent idea of the deal? Go ahead.
So like adherence to requirements, like that's sort of gonna like go along with the final presentation, right? So it's gonna be like 50%, but like 10% is gonna be the presentation, and then 40% is gonna be like.
Well, not necessarily. So the adherence is more of the so adherence and final project that's more of me going through the project with you kind of on the side, let's say, and saying, okay, show me where you've done this, show me where you've done this, show me where you've done this, so we can mark off those requirements documents, and that'll be 40% of your grade. And then, in terms of a final deliverable, what's the quality of the project? That can be completely different than your final presentation. I mean, you might come up here and do a really good presentation or really fake it well, like you basically have like nothing. Okay, you got this like shell of a game or something like that has nothing in it, but you like make it, you sell it, right? You come up and give this like great presentation, and everybody in the audience is like, oh my gosh, that was so good, blah blah blah. Then when I actually get in there and we look at it, like it's like there's nothing, like everything was a facade. It's kind of like the guy that like wraps toilet paper with a couple of $100 bills and pretends like he has a bunch of money on him or something. I wouldn't do that with toilet paper probably, but if you're desperate, you're desperate. That's exactly, exactly. Yeah. How do you make nothing look like something?
It was his words.
That's an excellent example, actually. Okay, so does that make sense? What the deal is? All right. So let's then. How many of you in here do not have a computer at home that you can work on? Everybody has a machine they can work on at home? Okay, so Unity works on both Macs and PCs. So you're fine there. I'm going to kind of take you through the process. When you go to Get Unity, so you'll start off, it's called Unity 3D, and I'll put links to these up on the Blackboard thing. So you go to Unity 3D's website, this guy. The newest version of this is 2017.1. So if you click on Get Unity, it's going to take you to this screen. You want the personal one, the one that's free, so click Try Personal. You click this little box here, you say download installer. The installer is pretty small, and then it downloads the larger file. You'll probably want to get it downloading like before you go to bed or something, depending on your internet speed. I want to say it's maybe total like maybe a gigabyte download, something in that ballpark. So if you're here on campus, you might want to give it a long weekend. Or it could be two minutes. It's just kind of a coin flip. So anyways, get that downloaded. Now, how many of you are Mac users who are going to be installing this on a Mac? None of you are going to be installing it on a Mac? Okay, well that's good. So I'll just say it out loud because I'm going to be demoing it for you on a Mac. I could boot into Windows on this, but I really like my screen capture software that I use for Mac. It works better than the Windows equivalent of it. So, but when you install this on a Mac, it comes with an IDE, an integrated development environment called Mono. Okay, Mono ships with it. Nothing wrong with Mono. Mono's a free IDE kind of based on Eclipse, if you've ever worked with Eclipse before. Now, if you go over to the Windows side, though, and you install Unity on Windows, it will install Visual Studio for you. It comes with it. And we're going to spend just a few minutes talking about why we chose Unity over like Unreal Engine or something like that, but a lot of it has to do with that connection with Visual Studio. For Mac people, we've lucked out that there is a Visual Studio for Mac. Now, at the end of the day, Visual Studio is just a text editor on steroids, right? But the way Unity interfaces with Visual Studio is much better than the way Unity interfaces with Mono. to the point that when you want to put in functions, when we start writing some functions, and we'll see some of these today in Unity, the Visual Studio tool will go ahead and do command completion for you for like the function names and stuff like that. That makes life a lot easier. Mono will not do that. So Mono, you're going to have to do more of don't mistype it yourself, that kind of stuff. But if you're all doing it on Windows anyways, it'll come with Visual Studio. All right, so get that installed, I would say, as soon as possible. So I'll kind of take you in here to mine. I'm pretty sure I have Unity installed on here. Yeah. Okay, so I'm going to go ahead and I'm just going to create a new project that we're going to be using today for some sample stuff. Yep.
You said something about like you were mentioning Blackboard. Did you open the class?
I didn't yet. I'll do it at our first break. The stuff's up there. I just didn't unlock it. Okay. So when you first come into Unity and you create a project, we're going to be working in 3D in here. Okay? So your Bible world will be a 3D thing. Now, let's see. Wherever you store it is fine. So I'm just going to go and call this 518 test and put it on my desktop. I have 3D selected. I'll do create project. And it's going to launch the editor here for this guy. Now, just for completeness here, if you went up to, I think it's in Unity Preferences. So if you were on a Mac, for instance, if you decide to put this on your Mac, if you go up to Unity, then Preferences, you go to External Tools, this is where it'll allow you to choose a different script editor, because the default will be the Mono Develop that's built in. So you would go and install Visual Studio separately. There is a Visual Studio for the Mac now. Yeah, and then you can choose that as the editor, and it will work better. All right, so that's the connection there. Okay, so let me get a Keynote open here. All right, and let's talk about why we are doing Unity stuff in here in the first place. All right, so one of the goals of this class is to give you an experience with tools that are related to what's happening in the world today. All right, as opposed to being a very theoretical based thing. We want this class to almost give you a project feel. I like to look at it like a startup company type feel, where you're working on something, but it's regardless of whether you love it or not. At the end of the day, at the end of the class, you're going to have this like completed project that you can like show off in your portfolio and say, I did this, I worked with this. And you know, it's going to give you a lot of experience with tools that you would use in industry. So I don't want to use kind of educational tools and things like that in here. I want you to have access to stuff that places in actual industry would use. Now, so the reason we're kind of going with this whole 3D gamey design type thing is this is becoming a pretty big deal in the world right now. How many of you, besides the couple of you who've worked on some of the projects with me over the summer, how many of you have used, who's never used Unity before? Let's go that route. Or if you've installed it and clicked on it, it was very minimal what you did. Okay. So most of us haven't worked in Unity. Now, the couple of people, well, okay, so when I say Unity to you, what does that mean to you right now? Like, what do you perceive that tool is? Okay, so platform for making games, okay, or 3D stuff, okay? Now, how do you think 3D games and things like that really play in today's world? Like 5 years from now, if you're out there and you're working, um, do you think you might be doing 3D game programming type stuff? You don't think so? No, you don't know that necessarily for sure. Why won't you be? Yeah, it's okay. And you don't think data analysis is going to be realized through virtual reality or augmented reality stuff?
Um,
Or is there, do you literally think there's no chance of that? That you'll be exploring stuff like that? Yeah, we'll see. I think we'll all be very surprised over the next couple of years. The number of things that will involve either virtual or augmented reality. All right, so virtual reality has become a pretty, a big deal in, let's call it, small circles, at least right now. We'll have to wait and see whether it becomes something that's as big as the internet or a fad that fades out. Because there's pros and cons. I think virtual reality is fun, definitely fun to play with. It's amazing that you can have these completely immersive worlds and you haven't left your house. So I think that's really neat. And I think, as time goes by, we're going to see more and more things that you'll be able to do in virtual reality that we're not even, considering today. I mean, being able to travel via virtual reality. You could be somebody who lives in Rome, let's say, and you want to take people on a trip around Rome, a day in Rome. If you were, let's say you wanted to go and visit Rome, plane ticket's kind of expensive, right? And you got to find a hotel there, even more expensive. Not a cheap trip to go to Rome, but maybe you'd pay $50 to go for a day trip to Rome, where you sit there and you put a helmet on and you're slurping a soda or whatever, and this person's taking you out around Rome, and you're talking to them, you're turning around, you're looking at everything as if you were there. I mean, that's kind of cool, and that's in the ballpark of what's possible. I think the things that are going to keep you from seeing too much stuff is going to be like, are they going to have rules in some of the public places that you're allowed to bring cameras and stuff in there? This guy comes in, he's got this like VR backpack set up with 3D cameras on it and stuff, and it's going to look kind of funky. Now, so that's kind of the VR stuff. What can you tell me about augmented reality? What is augmented reality? How is it different than virtual reality? Go ahead.
It puts stuff on top of things you're actually seeing instead of being completely different from what's around you.
Okay. Now, up to this point, virtual reality has definitely been more prevalent than augmented reality. Microsoft has a tool for augmented reality known as the Hololens. Now, it's still unclear whether the HoloLens is going to turn into something mainstream or whether it's only going to kind of live in maybe industrial markets or something. We have one here in the department. You can't buy them yet. It's a development unit. But one of the reasons we choose Unity for this class versus Unreal Engine, which is let's call it the Unity's competitor, is that you can only write HoloLens stuff using Unity. They have a plugin specifically for it. There's a arrangement between Microsoft and Unity, as you see by us when we install Unity. It comes with Visual Studio. So that makes Unity an easier choice for that, whether you do augmented reality stuff or not for the HoloLens. Now, what you're seeing, though, especially in the mobile world, and to be honest, I'm not even sure how far this is going to go, but Apple is kind of all in on this. Apple's gone all in now on VR. We'll see if they can play catch up there. But Apple's going to be announcing the new iPhones here in September, so almost this month, right? Starting tomorrow. They're going to be announcing the new iPhones, and it's going to be the new gadgets, new whatever, on a new faster processor, blah blah blah. But something that's at the heart of the new iOS 11 software that's going to run on these things is this thing called AR Kit, Augmented Reality Kit. So what you're going to start seeing is a whole lot of experiences for Apple devices, and I would expect you're going to see it very quickly jump over to Android devices, where the API will be there and the tools will be there on the devices, the cameras and things like that for doing augmented reality. So then we have to start thinking, well, how would augmented reality improve my life? You know, we've dabbled with augmented reality with different things. Remember Google Glass? So, yeah, we have a couple of those in the department. Fun for about a half hour. Then the battery dies, and you're gonna wait a while. But so it's a neat enough idea to have these wearables where, you know, you're walking along and you got this little tiny screen up here where you can get, you know, your text messages and stuff like that. You know, what's the point, right? So, you know, over the last couple of years, we've been dealing with this idea of wearables and you know, like Apple Watch. You know, a lot of people are like, well, what's the point of Apple Watch? Half the stuff that they brag about in the commercials that this thing does, I never use. It's clunky, it's kind of slow and sluggish. This is the second version, it's faster than the other one was, but I would say it's still not that useful, those things. But I get all my text messages on here, so I don't have to pull my wallet, I don't have to pull my phone out. That's beneficial because I mean, I get a lot of people messaging me, whether it's on Slack or just normal text message during the day, and I only want to reply to a very small percentage of them. You know, I have like my ordered list of people I care about. so at a glance, I can just see who messaged me and then choose to ignore it or not. So it's a communication tool for me. Outside of that, it's whatever. But from a productivity perspective, over the last several years as these wearables have kind of become popular, you know, we've really found very small uses for them, right? You know, Fitbits, a lot of people have kind of gotten into that. That's counting your steps and things like that. That's beneficial. Some people kind of like that you know, real-time measuring of your performance and that kind of stuff. But when you actually think about attempts that we've made to have these wearables change your life, you know, change the way you interact with technology and stuff like that, they really haven't made a difference yet. So now it's going to be interesting that they've given developers these tools for augmented reality. So ARKit, you can use Unity to write software for that as well. You know, now that they've given these people these tools to do that, it's going to be interesting to see what ideas they come up with over the next year or 2 years for things that we haven't even considered can be done in augmented reality. You know, think about the experiences that are on mobile phones today, just in general. You know, we go back 9 years, I guess now, and I mean, there wasn't even an app store. So having the mobile app store is only 9 years old. Now it's just, oh, there's an app for that. And, you know, but when it first came out, people were like, okay, what should the app do? What do mobile apps do? And then over the time, we've kind of come up with more and more stuff that like, how did we ever live without that app? That kind of stuff. I mean, do we even know what the weather might do outside if we didn't have an app? Do we actually watch TV anymore for the weather report? Do you even still give weather reports, or do they just have like a wizard come out there and do the magic 8-ball thing?
Well, they come out and hold up the app and show you.
Yeah, they hold up the app. That's right. But as an example, the micro weather apps. So I use a micro weather app called Dark Sky because I golf pretty often, and sometimes I'm out there when it's questionable weather outside, and I don't care if it's going to rain somewhere nearby. I want to know if it's going to rain here. And Dark Sky uses, I mean, I wouldn't say it's perfect, but it's surprisingly accurate, where it'll say, you know, drizzle starting in 5 minutes or something like that, and it's where I'm standing. So, you know, it gives you a lot of information. So my wife might message me and say it's pouring at home, but it might still be sunny on the golf course where I am, and it might be 15 minutes away. So it's, you know, these are things that we wouldn't even have realized, you know, we wouldn't even considered it being a thing 10 years ago. That wasn't part of, you know, what we thought about. So I think it's going to be very interesting over the next couple of years how augmented reality and virtual reality, now you got this mixed reality thing, which is effectively virtual reality without the sensors. So we have a mixed reality helmet in the department as well. And the way it works, if you have an HTC Vive or an Oculus Rift, one of like kind of the mainstream VR stuff, you have these sensors you have to set up and calibrate, and it's not that big a deal. It only takes a couple minutes, but really once you set it up in a room, you kind of want to just leave it, right? You don't want to touch it again because it just works. Well, with the mixed reality helmets, and I'll bring one in next week. You can, all it is the helmet itself, and it plugs into the computer. There's no sensors or anything like that because the helmet has 2 cameras on it. And when you set it up, the cameras read the room. So, and it also tracks your hands and that kind of stuff. The accuracy isn't quite, at this point at least, isn't quite as precise as the VR setups are. They have all these like sensors that are very specific for precision, but it's pretty good when you consider that there's no setup. Initially, Microsoft's idea for these mixed reality things to kind of work with Windows 10. Windows 10 is going to have a kind of a virtual, they would call it a mixed reality desktop, where you would sit down on your computer, put the helmet on, and you use your computer from within mixed reality. Is the idea. So your actual operating system, this idea of your desktop now changes. Instead, your home screen is your home. So you're in like this house that you can walk around in the house and teleport around and that kind of stuff. And you could put different applications on walls and stuff. Not sure I'm sold on that, because one interesting thing we're going to find in VR, and something that especially the second half of the semester, is you're starting to move your projects over to the virtual reality side of things. We will have several VR setups here that you can test your stuff on during class and ask questions, and we can debug things that aren't quite working right and that kind of stuff. So that's how the second half of the semester, at least class time, will primarily be used. So we'll have those set up so you have access to them here. But one thing one thing Microsoft was really pushing with this mixed reality stuff was the cost. Like, oh, well, the price of an HTC Vive was $800. And the price of an Oculus Rift was $600. These were expensive, right? Well, the price of a mixed reality helmet is going to be, let's call it $300, something like that. Well, now the price of VR stuff has come way down. You can get an Oculus Rift for $400 with the sensors. Yeah, you can get now you can get an HTC Vive for $600. So that's less compelling now, unless they come up with something that's really advantageous with the mixed reality stuff. If you're giving up accuracy, if it ends up being substantial accuracy you're giving up, it's probably not worth it. If they end up getting the accuracy caught up, and right now it's in development, you can't buy them yet. So I don't want to judge. I don't want to be too judgmental of the accuracy of it yet. But assuming the accuracy is pretty good, the advantage they have is that the setup is easy and you can take it with you. But I'm not sure the use for it is going to be being productive. I don't think you're going to throw your mixed reality helmet on and write a paper. I don't think that's the use for it. Okay. But in any case, kind of, the reason we pick a topic like this for 518 this time, last year we used, we did Node.js and what else did we do? Angular. We did Node.js and Angular in the last class. So we used technologies that were very popular at the time and kind of gave students projects to work on related to that. So now we're using an industry standard tool that you might find having a skill set in this is going to benefit you over the next several years. There will be companies that are going to do augmented reality stuff. They're going to do virtual reality stuff, and this is the tool they're going to be using. All right, so you'll be able to claim you have experience with this. Okay, let me quickly give you the Unity versus Unreal thing. So there's kind of 2 competitors out there at the, let's call it the professional level. We have Unity and something called Unreal Engine. And then you have lots of different video game companies have their own proprietary stuff that they don't let other people use. So there's other competitors, I'm sure, but nothing that we have access to. These are the 2 that we have access to. So Unity The scripting language we'll use is C#. You could also use JavaScript in this, but we're going to use C#. Unreal uses C++, and they also have something called visual scripting. And the visual scripting is all drag and drop. So you don't actually write any code. Instead, you do dragging to code stuff, which at first seems interesting, seems cool. But I think the reality of that, maybe the weakness of that is you do have some limitations. And if you rely on visual scripting to do everything, you're not going to be able to accomplish some things you might otherwise want to do in your project. Then you have to fall back onto an older language that's probably going to be more difficult to pick up if you haven't programmed previously. So I think C# probably makes more sense for the modern programmer, even though there's nothing wrong with C++. The language is fine. But I think if you had to learn a language for the first time today, and you had to choose between C++ and C#, I think C# is more marketable, I think is the punchline. Now, both of these support, so this guy will deploy for VR. Well, let's actually call it this. We'll say this Steam VR. Oculus VR is called Oculus Home. iOS, Android, PS4, several other things. Same thing is true down here. We can pretty much write the exact same list, but where we're going to have some changes up here is going to be this guy's also going to support ARKit, which is kind of the new cool thing from Apple. Well, we'll assume it's cool. We'll see if it turns out to be something really neat or if it turns out to be a big flop. And it also supports the HoloLens. All right, so at the very least, there's two things Unity supports that Unreal does not. So might as well learn that tool. All right, so let's talk about what a game engine is. What are these tools for? So, you mentioned that Unity, that when you think of Unity, you think of it as this platform for writing games. Okay. And maybe we'll expand that, at least for us, to kind of bring it into our world in here. It doesn't have to be a game. It could just also be 3D experiences, right? Because, this isn't, I'm assuming you're not going to turn your Noah's Ark thing into a first-person shooter. Okay, where your guys just reload. And so what we're doing in here is less about video games. Now, that doesn't mean you can't make a gamey type thing with your Bible story. You might pick a Bible story that has some combative nature to it. A good example here might be David and Goliath. Why can't you do the whole, slingshot thing, right? And actually, aim and have to. It's kind of a game, right? I mean, you could do that. That's up for grabs, by the way. You can do the David and Goliath story if you want. It's David and Goliath is the story. So it's this little guy. He ended up becoming King David, but there's this little guy, and he had to fight this giant, and he killed him with one little stone with a slingshot.
We actually share so many stories in Quran.
Okay.
From Bible, so I can recollect many of them.
Mm-hmm. Is that one of them?
Yes, I think I do not know. Names are different, but roots they've been same.
Mm-hmm.
So when you say Noah, we say Nu. So when you talk, I don't know, David refers to the who in my Quran, but I think I can get back to the story with some similar name.
Okay.
Yeah, so it's maybe Sam.
Okay. But that would be a type of story that would be more of a like a game, right? You could turn that into more of a game than experience. So, it's not that you can't make these games, but you don't have to make a video game. It can be a 3D walkthrough thing where, like, for example, the current part of the Bible VR group, they're working on the Moses story, and So this deals with the Jews' exodus out of Egypt, and so God talks to Moses through the burning bush, says, "Go talk to Pharaoh, tell him to let my people go." Moses goes and talks to Pharaoh. Pharaoh says, "No way." And then the first thing Pharaoh does to further punish the Jews is he tells the Egyptians. So some of the Jews were making mud bricks, and he tells the Egyptians, "Don't give them any more straw." Because straw was one of the ingredients for their mud bricks. You needed straw and water and mud to make your mud brick. Well, so before the Egyptians were providing the straw for them. Well, now they weren't. So now we have straw hidden around town. So, you're playing as a Jewish worker and you have to kind of traipse around town and go and collect straw, bring it back to your station, your workstation, and then, put mud in there, put water in there, put straw in there, and poof, you get a mud brick. So you make a couple of mud bricks and now you've completed that game because you've lived, you completed that little mini game. You've lived as a Jew that was deprived of the straw, and then from there, goes back and talks to Pharaoh, and the first of the 10 plagues, blood to water happens, and stuff like that. So, that these are all game mechanics, but not necessarily a video game, right? If it takes you a little extra time to make your mud brick, in that scene, you're not losing points. You're not, there's no real cost. You're just kind of, the idea is you're trying to experience what it would have been like to be essentially a Jewish slave in Egypt at the time. That's kind of the deal, right? So I expect what you're going to be making will be similar to that type of thing. If what the story you pick makes sense for a game, that's okay. You can make it more gamey, but it doesn't have to be. All right. So if you're not a video game person, you don't have to look for a way to lose. It can be just an experience as you're going through the stuff. Okay, but let's think about what some of that platform, the Unity platform, is doing for us that we don't have to do for ourselves. So everybody in here has had some programming, right? We've programmed in some language. What languages we programmed in? Okay, C, Java, Python, C#, Java, R. Of course you would say that. Other languages too. Well, R is Java syntax.
Kind of.
Yeah, isn't R is based on Java? Am I thinking about a different language? I think R is based on Java.
Just read that was based on something called S.
Yeah, I must be thinking about something else. What else?
It doesn't look similar.
What have you worked in? C? Only C. Old school. That's old school. So what kind of stuff have you done in C? All right, so networking stuff. Okay. All right, so we've all had programming at some level. And we're used to working with, whether it's an IDE or if you're doing protocol stack stuff, you're maybe using a text editor or something like that. But, whatever. We're used to those tools of you write some code, you put it into the compiler, you compile it, you test it, blah, blah, blah. So that workflow makes sense for us. Well, a lot of times, so maybe with network programming, you might not have an interface. Or if you do, you have a very simple interface you might slap together for testing it. So a lot of times, especially when you're a beginning programmer, the interfaces you're making for your applications are usually text-based, right? There's just more test stuff like, please enter a number, and then it spits out some stuff. What I like to do in my programming classes, when we get into like the intermediate classes, I like to start working. We use Java typically because it's a good teaching language, just because I don't have to worry about what kind of machine people have. It's actually another reason. I'm not 100% positive. I think Unreal only runs on PC. I don't know if Unreal Engine's on Mac. I'm not positive about that.
I believe that's correct.
But Unity is definitely on both, so at least it supports, so I'm being consistent. Because Java, I can use Eclipse to teach Java in class. It doesn't matter if you're a Windows user, a Mac user, a Linux user. Everybody has access to the same tools. All right, so I don't have to manage a whole bunch of different people's setups. But in any case, we're used to working in environments that do some stuff for us. And when I'm teaching these intermediate classes, I like to use, as soon as we can get to that point, I like to start doing Android development. Main reason for it is we're still learning Java. We can still work with the Java, the primitive stuff, but all of a sudden we don't have these boring interfaces anymore. We can start incorporating text boxes and buttons. They're not super, super exciting interfaces, right? But we start introducing the idea of graphical user interfaces and the whole event-driven programming where you have functions that get called as a response to a button click and that kind of stuff. It makes it more interesting. And the thing I've usually referred, kind of the example I give is, you've ever had a pet, like a dog that needs medicine. Usually you hide the medicine inside of some good tasting food and the dog will take the pill, right? So you hide the medicine inside of the dog's favorite treat and the dog will eat the treat and accidentally take the pill. Same thing's true when you're trying to teach some computer science theory stuff inside of something that maybe looks like it's fun. So whether we're doing game programming or Android programming, we're going to hide some theory stuff inside of something that's kind of interesting and fun, and hopefully you come out on the other end being force-fed something that was reasonable, and also had some fun at the same time. So when we start thinking about video games or 3D experiences, that kind of stuff, there's some constant things that are always going to be in these things, and the big thing for us is going to be physics. Okay, so physics, let's basically just say gravity, but there's more to it than that. How things respond when they bump into each other and things like that. This is a major, major part of what a game engine is providing us. Okay, it's done all that math stuff. So any of us could take a physics class. We can learn all the formulas, the calculations for how hard what will happen when a mass hits something else of a different mass, who's going to bounce back and how far and all that stuff. We can go and do that. We can even write functions that do that. But what a game engine does is it gives us a lot of those tools for us so that we can just start focusing on solving the problem at hand. Now, that doesn't mean that in some situations we might not choose to go ahead and rewrite part of that. We might be creating something that's maybe a little bit different than normal, or doing something that's very, very, very specific to a certain kind of maybe AI, artificial intelligence element or something like that, where maybe the built-in system just isn't, it's good enough for like most things, but maybe not quite good enough for what you really needed to do then. So maybe you write your own type thing. So having said that, another thing that's usually built into game engines is some artificial intelligence stuff. Big one being pathing. So how do you make a dude go from one place to another place and not bump into stuff? There's all sorts of algorithms that we teach in computer science, like the A-star algorithm, which is a pathing algorithm. How do you find the shortest path between 2 points, taking in the consideration the surfaces that are walkable? Fine, that's interesting. Study that, but if you're just trying to create a scenario where you have a monster that goes from here to here and he has to walk around a couple of houses, or maybe you're doing an Egyptian scene, so like Joseph was working on this summer, where he had to have a horse that was walking around town. Well, so you use the built-in artificial intelligence system to allow that horse to path around and not walk through houses. For a little time, we had a little issue with sometimes the horse would pick up a fountain. His butt would kind of get caught on a fountain. He would just drag that for a little bit. But, the idea is that those things would be very, very difficult, very time consuming to write yourself. Not that it can't be done, but it's one of those things that you don't want to spend a whole lot of your time on that. You want to spend your time focusing on kind of the bigger scene, the bigger experience. The guys this summer probably spent, I would say, at least just a couple of weeks building out this whole Egyptian village. And at the time, it really didn't do anything. I mean, this was all just designing throwing things out there, making it look Egyptian-y, right? Things like that. And then you start bringing life to it. So he had animals walking around and that kind of stuff. And then we put a player in there where the player can walk around and check stuff out. And that kind of goes into, if you were building the Ark, maybe, be able to go into the Ark and explore the Ark. That kind of thing, and get a feel for the space, because as soon as we bring this into virtual reality, now we're going to have the sense of size. So when you're playing a video game and we're just looking at the screen here, you don't have that size perception. You can kind of say, oh, okay, well, I see a car over there, and I'm in this boat, and the boat's a lot bigger than the car, so not that Noah's Ark and cars would be sitting next to each other, but but assuming they were, you can then get a perspective, right? But if you're in virtual reality, the perspective is relative to you. You can decide how tall you are in virtual reality, and then when you're standing there and you're looking around, you're looking at the inside of the Ark or standing outside the Ark as if you were there. So if it was you that was there, that's a very different perspective. So kind of an interesting thing. So at the end of the day, what a game engine is doing for us, it's doing a lot of those tedious mathy things that are very, very, very important, but there isn't a great reason that we need to reinvent the wheel, because every single game is going to have the ability for a solid object to have gravity. So if you let go of it, it drops. That's a thing. Okay? So if there's 10 games that come out this week, it would be very inefficient for all 10 of those games to have had for them to have to write their own how does gravity work functions, right? When it's already been, let's call it perfected. I'm sure there's flaws in maybe the built-in gravity engines, and if somebody is building maybe a space game or something like that, they might have a reason to change the way certain things work, or take some liberties to make it feel better. Maybe what it actually would feel like doesn't really play that well, or something like that, if you're trying to make it feel real. But the game engine is doing a lot of that stuff for you. That make sense? All right, so that's what this dude is doing for us. Now, let me just give you the quick little tour of Unity, and then we'll take a short break, and we'll come back, and then we'll start doing some stuff in Unity. All right, so Unity itself, and we'll have to see once we get into this, has multiple panels by default, and you do have over here, you have a couple of different setups, so you can customize your setup in a different way, but this is the default setup that you're looking at here. So that's what I'll usually work with. So what you have down here at the bottom is your assets. So what this guy is kind of your folder that has all the stuff associated with the current scene you're working in. So when you think about Unity, think about it as if you were directing a movie. Okay, so a game is a series of scenes. Okay, so if you were making a movie, you would have the opening scene, and then then there's the scene at the restaurant, and then there's the scene out by the pool, and that kind of stuff. So each scene is going to be, that's how Unity gets mapped out. Okay, so a scene is effectively a graphical map that you'll make. Now this asset thing down here, you can put folders and things like that down here. This is available across all scenes. So your scenes will get stored down here as well. So if I just go ahead and I hit save here, it's going to save this very first scene. So I'll just call this guy main. And it's going to save it in my asset folder. So now I got this guy down here called main. All right, that's my first scene. Now, if I have a second scene, and so if I go and create a new scene, I have a second scene, I can then double click on these two guys and be editing different scenes at different times. This is my scene editor up here. This is where I get to drag stuff in, and notice that it comes by default with a main camera and a directional light. When we go into VR stuff, and I'll actually show you how it works today, just so you get the concept of it, even though we don't have a VR thing hooked into this. I'll try to get something set up for us for next week, because we're getting our VR stuff set up in the next room. But just to show you that it's not that big a deal when we go from just 3D to VR. That's not the end of the world. Okay, but right now this is set up just to be a 3D thing. So they give you a camera, they give you this main camera, and then they give you a light source, because if you don't have a light source, everything will be dark. Okay, so this main camera, if I click on this guy, I get this little camera preview here that shows me what the scene would currently look like. If I want to go ahead and I want to right click in here and I'm going to create a 3D object, I'm going to create a cube. So that puts this cube out here on the screen. Notice here when I have the camera now, I look at the preview, the cube is there in the scene. So if I go and hit play on this, there it is. So the camera is back here and I'm seeing the cube over there. Okay, and this is the angle of the camera. So you see these two lines coming out here. That's how the camera is being shown. Go ahead.
So is this a little bit like when you're working with Alice, for instance? Like, I know like the coding.
A little bit.
Pretty different. But.
Yeah, it's a little bit, but not just the very basics would be similar. Yeah. Okay, so I've put a cube in here. In my scene. So here's my cube. If you double click on it, it zooms into that object. This is actually going to be interesting because this is different controls that I'm used to seeing. So that's so maybe 2017.1 isn't quite identical to the previous one. Oh, that's the resize ones. I bet you. No, movement's good. That's fine. All right, so when you click on, these things are game objects. So let me kind of come back here. That's going to be a pretty important primitive. So when we talk about primitives inside of Unity, everything is a game object. So our most generic thing is a game object. So a game object has a transform. So a transform is a vector 3 location in 3D space. All right, which is, vector 3 sounds a little intimidating, but it's basically an XYZ coordinate. That's what a vector 3 is. Okay, so game object has one of those. But now, game objects don't have to necessarily be visible. For example, I can come in here to my scene and I can create an empty game object. This is something that people won't see in the scene. It's not going to be visible to the user. But you might want to have something like this to allow you to communicate between multiple objects in your scene. If you've ever worked with singletons before, sometimes you need kind of a global variable that's available to everybody. You would put that inside of scripts that are attached to this global game object. I'll show you examples of that today. But not all game objects are visible, is kind of the punchline. But our most primitive thing here is a game object. And then game objects come in a couple of different flavors. We have cubes and spheres and capsules and cylinders. We have planes. So these are all things that you can create that are kind of pre-built game objects plus a little bit of something. So a cube has a, has a size to it. Same with a sphere. These are your primitive types that you use for building stuff. All right, so anything that we have as a game object, we'll see that through scripting here in a few minutes. Now, when you click on one of these game objects, so I clicked on my cube here, then you come over here to the right side, you have this thing called the inspector. So the inspector shows you all of the, let's call it details associated with this particular game object, the game object you have currently selected. Now, notice that this guy has a transform. So all game objects have a transform. They have an XYZ position. So if I come here and I create an empty game object and I click on that, notice that all that guy has is a transform. So a game object in its most simple form is a location. And he's actually invisible in his most simple form. You can't see him at all. But this cube, which is, let's call it a specialized form of a game object, he has a transform. He also has this mesh, okay, and the mesh is built into Unity. This is effectively a jumpsuit. Okay? He's wearing a jumpsuit that makes him look like looks like a sphere. I'm sorry, looks like a cube. Then we have this guy called a collider, a box collider. This allows, so this comes with cubes by default. This allows this guy to bump into other things if we want him to, and we'll experiment with that after we take a break. Okay. Then we have the mesh renderer. This is the thing that actually takes your mesh and makes it show up with different light settings and things like that. Okay. So notice if I turn that mesh renderer off, you have little check boxes here. We no longer see the cube, but we do have the filter of it, so we have the cube-like suit that we still see there. Not until I actually turn the renderer on to show that suit does it show up as something. Okay? But so this is our list of components that are associated with a game object. Now notice down here that we can add components to a game object. So we have a big list of things that we can add to a game object. We could add meshes and effects and physics things and navigation things and audio and blah, blah, augmented reality stuff. So there's all sorts of things that we can add to a game object. A common thing we're going to add is something called a rigid body. Okay, and rigid bodies, these are the guys that this guy's a rigid body. How do you know? Rigid. Trust me, my knuckles would agree. This is rigid. All right. So when you have something physical like this, this is where we can start choosing whether we want gravity to play into it. So because I've decided that this cube is actually a rigid body, I can say go ahead and turn gravity on. I'll hit play here, and he's gone. If you want to see that again, if you missed it, there he is. There's gravity, because he had nothing to fall onto. Yeah, he just fell out of the sky. He was in the sky, he just fell. I can decide that he's going to be a rigid body, but I don't want to have gravity on. So I can turn the gravity off on that guy. Go ahead and hit play. Doesn't do anything. So now he's technically still a rigid body. He technically still has a box collider, but he's not falling out of the sky himself because we turned gravity off for him. But now, because he's a rigid body, so this is this example. So I have this guy. We know this is a rigid body, and I'm going to poof, turn gravity off. That would be really cool if I would, I just let go of it. It was hanging there, did a David Blaine magic trick or something. Okay. So I let go of this. It was still floating there. So gravity isn't taking part in this. Here, we'll pretend like there aren't legs on this table. This guy's a rigid body, right? And it just happens to be floating above the floor about 3 feet. Pay no attention to the legs. But I turn gravity off for him so he doesn't fall. But now this is a rigid body that has gravity on. I let go of that. When he hits this, he's interacting with another rigid body. Does that make sense? And when rigid bodies interact with each other, their physics occurs. Okay? These things physically interact with each other and stuff happens. What a game engine is doing for us is it's making the stuff that should happen happen. All right, that makes sense? So every game object is going to have a list of components associated with it. And those lists of components are going to drive what we do with that thing. All right. Now, let me just show you this last piece here. I can come down here, and I'm going to go ahead and I'm going to create. So I'm down in my asset folder down here. I'm going to right-click. I'm going to say create, and I'm going to create a C# script because we're going to be doing some programming stuff. Okay. Never click on JavaScript script because just don't click on JavaScript. It's stupid. There's plenty of people. You'll find plenty of examples out there in JavaScript, but you want to write it in C#. You'll find better examples in C# for serious stuff. Okay, so we'll create a new C# script. We can name this guy whatever we want. LOL. Okay, this is our LOL script. So now when I double click on that guy, because I had set Visual Studio as my default editor on my Mac, it's going to open in Visual Studio. If you're on a PC, Visual Studio will be the default editor. One word of warning I'll give you though is when you install this on PC, it's going to first pop up. It's going to seem like it's an error message, like you think something went wrong. It didn't, but it's just really weird how it pops up. It's going to say we could not detect if you have Visual Studio installed. Just hit OK. It will install it with it. Okay. The other thing I'll say related to that is You might want to, when you first install Unity, it gives you the choice of it gives you the default stuff it'll come with. But if you want, go ahead and check iOS and Android support as well. That way you can export your projects to those platforms. And also, if you wanted to play with ARKit or something when it comes out, you already have the packages there. Effectively, it's just 2 little check boxes you'll click, and it won't make your life any different other than 300 or 400 megabytes. It'll make you 300 or 400 megabytes heavier when you do it that way. All right, so what gets created here is a script that looks like this. All right, and when we come back from break, I'm going to talk about these scripts. I'm not going to do anything with the scripting right now, but I can edit this script and things like this. And then if I want, I can click on my cube game object, and I can drag that script over there. So this guy now has as one of his components this LOL script, whatever that means. So that's code that I wrote might have an impact on this game object because I connected that script to it. That make sense? All right. So let's call that the nickel tour of the Unity interface. This is where we design what our scene looks like. This is where we keep our files. And here's our editor over here where we write our code to do specialized stuff that we can't make work in real time. Okay, so let's take about a 10-minute break. I will get the course unlocked. And, well, I'm going to take a break too, but then I'll get the course unlocked. And then we'll come back and we'll start looking at some more details in Unity and player movement stuff.